Hi everybody, I'm Mike Poland, the scientist in charge of the Yellowstone Volcano Observatory. This is the monthly update for August 1st of 2022, coming to you today from beautiful Mammoth Hot Springs in Yellowstone National Park. Now I thought over the next few months we might talk about the different types of hot springs that we can see in Yellowstone. There's three different types. There's neutral chloride hot springs. These are the types that we might see around Old Faithful area. There's acid sulfate hot springs, something typified by Mud Volcano. And then there's travertine hot springs, and that's what we have right here at Mammoth Hot Springs. Now, travertine is sort of a different type of hot spring. It's cooler than we see in the other areas of the park. And the chemistry of the springs here is also different. It's controlled by the subsurface geology. Now, we're outside the caldera here, well north of the caldera. And the rocks beneath us are actually made of shallow marine sediments. This whole area, tens of millions of years ago, used to be a shallow inland sea. And so there are lots of sandstones and slates and even limestones that are composed of the shells of small marine organisms that have accumulated over time in this area and became part of the bedrock geology of the region. Now, it's also a zone of persistent hydrothermal activity and faulting, and so hot fluids from the Yellowstone caldera area can migrate up in this direction. And as those hot waters interact with those marine sediments from that shallow sea that existed tens of millions of years ago, they pick up calcium carbonate, that limestone material that's part of the sediments. And as it rises to the surface and gets to the surface, it drops that calcium carbonate. And so that's how you get these beautiful terraced springs. It's made of calcium carbonate, basically the same thing that we see in marine limestones, but here at the surface deposited as a hot spring material. And we see this sort of hot spring material all throughout the Mammoth Norris area. In fact, even north of the park. There's some hot spring deposits near Jardine or Leduc Hot Springs, and south of Mammoth Hot Springs, Terrace Mountain is one of the oldest hydrothermal areas that's known in the park, about 400,000 years old or so. So travertine is kind of an interesting aspect of Yellowstone's hydrothermal system, not like the stuff we see in the caldera. There's a few minor travertine springs in the caldera, but really what we see here is pretty unique, all because of the subsurface geology of the region. Okay, now let's talk about what happened in Yellowstone in terms of seismic deformation and geyser activity during the month of July.
Over the past month, we saw normal background levels of activity in the Yellowstone region. The University of Utah seismograph stations, which is responsible for the operation and maintenance of the Yellowstone seismic network, located just 59 earthquakes in the region during the month of July. You can see they're spread sort of throughout the region, but most of the events occurred in this belt between Hebgen Lake in western Montana and Norris Geyser Basin in Yellowstone National Park. This is where most of the seismicity in the Yellowstone area occurs historically. Now, the largest earthquake of the month was a magnitude 3.1 that occurred about 14 miles or so south of Mammoth Hot Springs in Yellowstone National Park. And this was a part of a small sequence of earthquakes, 13 located events that occurred right at the end of the month. So, normal background levels of seismicity in July in Yellowstone. Turning now to ground deformation, this is vertical deformation at the White Lake GPS station, which is located on the east side of Yellowstone Caldera on the Sour Creek Resurgent Dome. This plot spans the past 2 years. Each one of these dots represents a day of data. Downward trends indicate subsidence, the ground going down, and upward trends indicate uplift, the ground rising. You can see over the last 2 years, and in fact going all the way back to 2015, there's been an overall trend of subsidence. But it is interrupted in summer months by a pause in that subsidence or even a slight amount of uplift. You can see it here during the summer of 2021, and again ongoing right now during the summer of 2022. This is caused by water from snowmelt that percolates slowly into the ground and then causes the ground to sort of puff up, just like a sponge getting wet. And we see this throughout the region. For example, this is GPS data from the west side of the caldera. This is close to Old Faithful on the Mallard Lake Resurgent Dome. And there's an overall trend over the past 2 years of subsidence, but during summer months, like here in 2021 and happening right now in 2022, that subsidence pauses or even turns around just a little bit. Due to water that's percolating into the ground and causing it to puff up like a sponge. Now, the overall subsidence rate is only a couple of centimeters a year, about an inch a year, and the amount of uplift that occurs over this time period is less than half an inch. So we're talking very, very small amounts of change. It also is being recorded in the Norris area. This is the GPS station over the last 2 years near Norris Geyser Basin. There's not a whole lot of overall deformation, but again, you can see during the summer months, 2021, and again in 2022, this slight amount of uplift that's caused by groundwater that's percolating into the subsurface. This large signal right here in late 2021 is actually due to snowfall, which covered the antenna and affected the way the GPS signal was being recorded. Now, if we look at the long term, you can see this signal quite clearly. This is back at that White Lake GPS station on the east side of the caldera, and it's since 2016. So vertical deformation overall is showing subsidence of a few centimeters, about an inch or so per year, but every summer, 2016, 2017, 2018, 19, 20, 21, 22, you can see that that subsidence trend is interrupted by a pause or a slight amount of uplift. So this seasonal signal is caused by groundwater that's percolating into the surface from snowmelt and causing the ground to sort of puff up. Finally, turning to Steamboat Geyser, everybody's favorite geyser, the tallest geyser in the world, we actually did not see any major water eruptions during the month of July. Now, this is a plot of the temperature that's being measured in the Steamboat outflow channel. All of this sort of very thick line, lots of up and down motion, is an indication of minor eruptive activity. We typically see a lot of minor activity before the major eruption. And this spans the last 2 months, so you can see a major eruption here on June 10th. Temperature dropped. We saw daily temperature variations, a lot more minor activity leading into a major eruption on June 20th. Then we went back to daily temperature variations. This is basically the geyser being dry. And then starting in sort of early to mid-July, we start to see this minor activity pick up again. So it looks like Steamboat is probably building towards another major water eruption, hopefully sometime in early August. So it looks like Steamboat is not done quite yet. It's not as active as it was in previous years, but still having a lot of minor activity, so hopefully leading to a major eruption soon.
Well, that does it for the Yellowstone update for August 1st of 2022. Now remember, if you have any questions at all, you can feel free to email us anytime. Our email address is yvowebteam, that's all one word, at usgs.gov. And next month, we're going to come to you from another type of hot spring in Yellowstone as we explore these 3 different areas of thermal activity in the park. So until then, stay safe, stay healthy. We'll see you next month. Bye-bye.